Absolutely. Here's a more in-depth expansion of the first part, focusing on elementary particles. Quarks are elementary particles that combine to form composite particles called hadrons, such as protons and neutrons. There are 6 types or flavors of quarks: up, down, charm, strange, top, and bottom. Each flavor has a specific charge and mass. Quantum chromodynamics, QCD, is the theory that explains the strong force binding quarks together within hadrons. It involves the exchange of gluons, which carry the strong force between quarks. Leptons are another family of elementary particles, distinct from quarks, and they don't experience the strong nuclear force. The most familiar lepton is the electron, which orbits the nucleus in atoms. There are also heavier counterparts like muons and tau particles, each associated with their respective neutrinos. Leptons interact via the weak nuclear force, which is responsible for processes like beta decay involving neutrinos. Quarks and leptons are grouped into 3 generations, each comprising 2 quarks and 2 leptons. Each generation has similar properties but with increased mass, and they exhibit similar quantum properties while being less stable. Quarks carry a property called color charge, which isn't related to color but is a property analogous to the way quarks interact through the strong force. This concept is part of the theory of quantum chromodynamics, QCD. Quarks have never been observed in isolation. They are always confined within composite particles, mesons or baryons, due to the strong force. Experimental facilities like the Large Hadron Collider, LHC, and various detectors worldwide study the properties, interactions, and existence of quarks and leptons. Experiments involving high-energy collisions and subsequent particle decays have provided substantial evidence supporting the existence and behavior of quarks and leptons. Understanding elementary particles is fundamental in unraveling the mysteries of particle physics, explaining the structure of matter, and advancing our comprehension of the fundamental forces that govern the universe at the smallest scales.